CCF, Eric Millbrandt.
Hey, thank you, Jennifer, for providing this platform for us to come together and talk about some of our work and our challenges and accomplishments. And I really miss the coffee breaks and the interactions and seeing all my colleagues, and hope to see you at a meeting or a function in the future. Next slide. So I'm going to talk about eastern oysters and oysters more broadly than Charlotte Harbor, but then talk about some of the projects that we've been working on. Oysters are important. They are a habitat type, oyster reefs. You can see them in Charlotte Harbor as many shapes. A lot of them are long and sinewy, and some of them are platforms, and some of them are just attached or under mangroves. But they do filter a lot of water, enough to fill a small bathtub. They're one of the most imperiled marine habitats on Earth. Estimated between 85 to 90% of wild reefs have been lost in the past 100 years. That's because of they're desirable as a food item, and they are also as great for roadbed construction, which is why we lost most of our habitats. They spawn tiny larvae, so you can actually put substrate in the right place in the intertidal or subtidal in certain cases, and restore reefs. That's what makes it very successful restoration project. They often live in kind of crappy water quality. So I saw there was a great question about water quality. They like algae-filled green water, but they don't like long periods of time with very low salinity. So I'll talk about our landscape scale approach and how we're thinking about this. Wild oysters can live 25 to 30 years, but don't typically survive really past 2 or 3 years in Charlotte Harbor. And the reefs provide a complex habitat for many marine invertebrates and small fish. So it's an important provisioning for those tiny organisms. And the great thing is oyster shells are recyclable from restaurants, although most restaurants just throw them away. Next slide. So I'm just gonna go through our scientific process for determining a prioritization strategy and a landscape level approach to reef restoration. We used a Trimble GPS with RTK, which is real-time correction, and the DOT in Florida provides base stations, so you can correct elevations to 2 centimeter accuracy in most cases. Next slide. So we used the elevations plus a rapid state index, if you will, to determine the health of the reef and where we were on the reef relative to elevation. So we used 3 different categories: substrate, percent cover, and percent live. Next, please. And we did this at several reference reefs that we know about at Tarpon Bay and in San Carlos Bay. Those of you familiar with Tarpon Bay, these are the rookery islands that are home to many roosting and nesting birds. And we used an approach to try and maximize the number of points along different elevations to determine what the optimal elevation to restore an oyster reef would be. Next. So the data was surprisingly revealing, and it showed that the optimal elevations for Tarpon Bay and San Carlos Bay was between -0.25 meters and -0.75 meters. And of course, this will change as you move closer to the mouth of the Caloosahatchee. You end up getting more ability for these oysters to survive in the subtidal. But in the lower estuary, they're subject to both marine predators and disease. So the intertidal elevation position allows them to thrive because they get relief from both of those stressors. Next. So we use a Backe approach, and as Joellen very wonderfully laid out for everyone, there needs to be a strategy for restoration. There needs to be data collected before and after in order to quantify and understand that what you're doing is really restoring habitat. Next. So our approach, you can see the Sanibel Causeway there on the lower right, Tarpon Bay. The star is our where our facility is. We have sites distributed throughout the area to be able to, during dry years, the sites that are located closer to the mouth of the Caloosahatchee, labeled the MPR, MPC, MP4, those will do better. And then during wet years, the sites in Tarpon Bay will do better. And that's been demonstrated by Swani Valetti's 10-year almost research in this area. At each location, there's kind of 3 different regions. We chose oyster reference sites, control sites where we weren't going to be doing restoration, and then restoration sites. And it turns out that for some of the control sites, we've been able to restore them. So we've moved on and picked new control sites. Next slide. So the process started on a small scale, and Joellen, it was exactly right. You learn iteratively a little bit doing these projects, and you can design your projects in the future to be larger and better and more impactful. But we started off just putting shell in buckets, not using plastic, and depositing them in a footprint that's permitted. Next. And more pictures of volunteers. Next. So I'm going to kind of go through some of these fairly quickly. This was an evolution also in our ability to survey. This was done using a laser level and a base station. That was before we got the Trimble RTK. But you can see the elevations here are a little bit deeper than the ideal place, but this was a site that was a relic reef. Next. So as built, we added substrate and tried to get within that -0.25 to -0.75. And I can tell you today that the areas that are in red and orange are doing well. The areas that are in lighter orange, the substrate is there, but predation and disease will not allow live oysters to continue to grow, but you get a settlement event every year, you get spat there, but they don't grow very large. But at the other sites, I'll show you data on densities in a minute. Next. So a year or so later, this is what that reef looked like, which, you know, astonished us. It really took off and established very quickly. Next. So you can see the densities at the site were very high initially. And what we've noticed that all of the reefs happen is that the oysters grow to a certain size, and then there's a few larger oysters, and then the densities actually decrease. But you get an initial settlement event, and then over time, over 2 or 3 years, the densities decrease, but the sizes are more representative of a reference reef. Next. And this is just a graph of the size. Sorry, the black is the restoration site. It's increasing generally. The red is a reference site, and the aquamarine is a control site. Next. So we scaled up with the grant from the FDEP, the same permit that we originally applied for. Next. And we had to get special permission and ordinance kind of approach with the city of Sanibel to construct using a boat ramp. Next. And big yellow machines dumping fossil shell. Next. And the reef. Next. And footprint. Again, look at the scale, minus 0.25 to minus 0.75. We did pretty good, although the footprint and the contractor were a little bit, the contractor was afraid to go into shallow water and didn't have a long reach excavator. So we're gonna try and go back and put more shell in the footprint that's existing there. Next. Okay, Corey talked about this. Next. And next. He went through and showed you this, but this is a really great project that, you know, we were very communicative with the contractor. We're able to get out there and survey elevations in real time and give him feedback, tell him, okay, this is kind of the way we want it. And he and his team did a great job. Next. And pre and post, we added, as Corey said, 700 plus yards of shell. Next. And that's the way it looks. Next. Next. So we've evolved our survey methods quite a bit. We now, in addition to using a handheld Trimble with the antenna, we've attached the antenna to a depth sounder on a vessel and used an offset and been able to generate a lot of points. Next. So the takeaway message is we really didn't change the elevation at all at this site. We just added substrate, and that's really important because we're not really trying to fill deep areas. We're actually just restoring intertidal areas that have lost substrate. Next. And next. So here's just some time series of, it's kind of hard to see because they're intertidal, but there's water flowing over them. And actually this site is really done well. Next. And next. And next. And this is one of the large pieces of fossil shell that's obviously covered with a lot of live oysters. And next. Okay, so again, let's look at the density data. Here we have restoration sites in both red. Well, the colors aren't great here, but there's two restoration sites, a reference site and a control site. The reference site is in red. The restoration sites are in black. One restoration site has black points and the other has red points. So initially you add the substrate and you get really high densities, 2,000 oysters per square meter. And these are surveyed using a grid with random numbers, and we collect typically 5 quarter meter square quadrats per site. But yet then you can see a decline in density over time, but then the size increases over time. Next. So here's the change in size distribution over time. Next. All right, so a couple things we're really excited about. We have permits to do 20 more acres. We did receive some SWIG funds to try and restore Hemp Key, and we're gonna do volunteer events at the end of the summer. So hopefully we can, we may be able to see you there if you're interested in that. We did submit a NOAA restoration grant. It's pending, so we're waiting to see. We do want to do targeted red drum sampling around the reefs to try and find out what fish are using restored reefs, but we'll have to wait and see if that gets funded. And next. Thank you very much, everyone. Happy to answer questions.
Great. Thank you so much, Eric. That was excellent. Again, we're going to handle this through the chat. And I know you were presenting some questions were coming in, so I'm just going to scroll up here and start with the first question, which is, have you tried using UAV-based topobathymetric LiDAR for your survey?
The answer is no, but we've looked at LiDAR data for other projects. It'd be interesting to see how well it does. We get LiDAR for free with the property appraisers and flood maps, so I should look at those. And I'll just read the next question because I can see it. Are there any areas off of Captiva that would be appropriate? Yes, there are. Many of the reefs that we've encountered are highly degraded, and then there's a few that are really in great condition. Right now, most of our efforts are focused on San Carlos Bay and Tarpon Bay because they are areas that are close to shellfish harvesting, and areas near Captiva close to shore are good because they're closed also, but in the middle of Pine Island Sound, there are reefs that are actively being harvested commercially and recreationally. So we want to avoid that because it's a rather large expense to restore a habitat. We don't want to just see it be decimated. So the next question is, are boat wakes an important stressor to reef development? Yes, but not so much at our study areas. All of our study areas are in manatee slow speed zones and no wake zones. So even Hurricane Irma had no effect on the reefs that were constructed. So it's definitely an important consideration when you're planning and permitting. It's for me this time, it was a 14-month permitting process. It's largely at this point, you need 2 permits, one from the state, one from the federal government. And then, we want to definitely encourage habitat restoration, but we don't want to also allow people to do marina development and call it restoration. So it's really an important part of this process.
All right, Eric, there was one second question to the previous person who asked the question, which was, have any grants been sought for that area of restoration?
So the way that the process works is you get the permit and then you apply for money, because a lot of times the funding is limited to a year and it takes over a year to get the permits. I've applied for funding for a lot of reefs from one agency, and it's probably a long shot at this point, but who knows. But yes, we did get a grant to restore Hemp Key, Baldwin Key areas near Demery Key this summer, and that'll be a 2-year project with FWC and U.S. Fish and Wildlife Service.
Great, just checking to see if any last minute questions have come in, but I don't see any. So with that, thank you so much, Eric, and hopefully you'll stay on the line with some of the next presentations coming up. People feel free to email Eric directly. His contact information is in the proceedings.